Hello grade 10s, welcome to this lesson about number patterns. Well, as you can see, there are two patterns that we'll be investigating today and discussing as to how can we master this topic. All right, so before we start, I believe you have something to write with and to write on, and let's go through the inquiry method here, okay, for this topic. The first question you want to ask yourself is what type of pattern is given. Okay, and usually at this level we only deal with linear patterns. The second question is what is the constant difference from one term to the next? What is that number that we are adding or subtracting each time to progress the pattern? Okay, and then the third question is how can I use the constant difference to find the general formula or the nth term of the pattern? Okay, and the last question is how can you now use the nth term of the pattern to find the value of any term or even the position of any term? Okay, because it's an equation, it can work in both directions. Okay, to find the value of a term or the position of a term. Okay, so usually a pattern will start at position 1, term 1. Okay, so we have two patterns here, and the three skills that I want to share with you that I believe this lesson will help you to master is how to extend a pattern, how to get the nth term, and how to determine the value of, in this case I chose 62. We're at position 62 in the pattern. What is the value of this position, okay, of this term in the pattern? Okay, so now let's deal with this one. Term 1, term 2, this is term 3, this is term 4, and the pattern continues, suppose to infinity. Okay, so what we want to do is to investigate what type of pattern is given. So it's 3, 7. Looks like we're adding 4 here. From 7 to 11, again, looks like we're adding 4. 11 to 15, again, looks like we are adding 4. Okay, I like to include the sign as well because it just makes numerical and mathematical sense. 3 plus 4 is 7, 7 plus 4, 11, 11 plus 4 is 15, and so on and so on. Okay, so we can clearly see that we are adding 4 from one term to the next. Okay, so let's do the first part of what we need to answer here. The first question is at the next two terms. So the last term that is given here is term 4. So the next two terms will be term 5 and term 6. So how can we get that? Term 5 will be what? We are at 15, and we understand by now, according to our investigation, that we are adding 4 each time. Okay, so it will be 15 plus 4, which is what? 19. Okay, and then term 6, what will be term 6? We are now, the previous term before, obviously, term 6 is term 5. At 19, what are you adding to 19? 4. And then you arrive at 23. Okay, so we've handled that part there. Now we want to determine the nth term. Okay, let me use green for this one, or the general formula. Okay, so I would like us to have a deeper understanding of what's going on here. We need to talk about this. Okay, the difference between consecutive terms is 4 each time. Okay, and when you talk about the positions, the difference between the positions is 1 each time. Okay, so what are we saying? 7 minus 3 is 4. 2 minus 1 is 1. 15 minus 11 is 4. 4 minus 3 is 1. And you can do it here as well. 7 11 minus 7 is 1, and 11 minus 7 is 4. So, sorry, let me just say that again. 3 minus 2 is 1, the positions, and 11 minus 7 is 4. Okay, so here it gives us a, it leads us to talk about gradient, because a gradient is your change in y over your change in x, and that ratio gives you what is called the gradient of a line, and that is a linear function. And by now I suppose and I believe that you do have an understanding and you are familiar with this equation, y equal to mx plus c, the standard format of a linear function, and this m right here is the gradient. Okay, and the gradient of a straight line is constant, and this is what we mean by this constant difference. Remember, a gradient is a rate of change, okay, from point to point. This is from position to position, and that change is a positive 4. Okay, so our m here, from that understanding, is a 4. Okay, it's very important to connect topics in mathematics, and that is how you build, okay, understanding and logic, and you are able to see the bigger picture and the beauty that exists within this subject. Okay, so the gradient here is 4. Okay, however, using the language under number patterns, we call it a constant difference. Okay, so that is a 4, and obviously there's a relationship between x and y, and that relationship is expressed by this equation. What does this C represent under functions? It is the y-intercept of what? The straight line. However, under number patterns, that will be a constant number that will either add or subtract to this product, okay, so that we get the values of the terms. Okay, so remember the inquiry question: how can I use the constant difference to get the what? General formula. Okay, so we're gonna do a mini investigation here, like this. Okay, term 1, we know that y is related to x. That is just how it is, because a function is a relationship between the x values in the domain and the y values in the range. Okay, what is term 1, guys? Term 1 has a value of 3. Okay, and how can we now come up with an expression that will help us deduce the general formula? So it's 3. Our constant difference here, our gradient, is 4. Okay, and then what is the input value? The x here, we are putting 1. Okay, the position of our term is, we're at position 1, and in position 1 the value is 3. Okay, I believe you can see the picture here, the connection. Okay, so it's 4 times 1 is 4. Okay, so what do we need to do to 4 to get a 3? We need to minus 1. Remember I said we can either add or subtract here. The y-intercept can be positive or negative, or it can be 0 as well. So it looks like, we're minusing 1 to that, but let's confirm. What is term 2? Term 2, it's 7. Okay, it's 7. What is our gradient? Our constant difference is 4. Okay, and we're at position 2. So in position 2, the value is 7. Position 2, the value is 7. 4 times 2 is 8. Okay, and again, 8 minus 1, it's 7. Okay, let us do the last one, because we need to do at least 3 checks, and through induction then you can talk about the general formula now. Okay, term 3, it's 11. Okay, what is our constant difference? It's 4. Okay, where are we? Position 3. Position 3, the value is 11. Position 3, the value is 11. 4 times 3 is 12. Okay. 12 minus 1 again is 11. Okay. So then we can make a deduction as to what would the general formula look like. The nth term. Okay. It will be Tn. Okay. N being the position of the term is equal to what is happening. It's 4n minus 1, because that is the relationship that we see. This n is that n there, just like it's 1 and a 1, a 2, a 2, a 3, a 3. Okay, and then we see that the 1 comes in there. I mean the minus 1, the minus 1. Okay, so that becomes the general formula. We can use it to find the value of any term. Okay, so that's it, guys. Let's go to the last one. Determine term 62. Term 62, how can we use the general formula to get term 62? The substitution must take place from the left-hand side to the right-hand side. Our n is now 62. Okay, so we have 4 times 62 minus 1. We can take out our calculators now and confirm what we have here. 4 times 62 minus 1, it is a beautiful 247. Okay, what does this mean? It means at position 62 in the pattern, the value is 247. Okay, so this is the process, guys, that we are seeing here in this lesson, and that I believe will definitely help you master this topic. Okay, so let's do this one. Okay, I have another pattern here. Let's label our stuff. Term 1, term 2, term 3, term 4. What type of pattern is given? Let us investigate. Okay, 0 to a negative 3, a negative 3 to a negative 6, negative 6 to a negative 9, and the pattern continues, supposed to infinity. So these numbers are decreasing. So it gives us a sense of subtraction as the operation here. Okay, so it's 0 minus 3. So it's 0 minus 3 gives us a negative 3. And negative 3 again minus 3 gives us a negative 6. And negative 6 minus 3 gives us a negative 9. And therefore, that, just like the previous pattern, it gives you what is called the constant difference. Constant difference. Okay, so let's do the first part of the question. At the next two terms, we're at T4, now we want term 5. Term 5, what is happening each time? We minus 3. So we're at negative 9. We minus 3. This gives us a negative 12. Okay? And then term 6, we are at negative 12. We minus 3. This gives us a negative 15. Okay, so we did add the next two terms. We know that we're dealing with a linear pattern and what the constant difference is. Okay, the next part, determine the nth term. Again, we need to investigate, because we are dealing with a function here. It's just expressed as a collection of numbers. Okay, y is equal to mx plus c. And we saw in the previous question that that m is your constant difference. Okay, because negative 3 minus 0 is negative 3. 2 minus 1 is 1. If you do it here, 3 minus 2 is 1. Negative 3 minus negative 6 minus negative 3 will give you a negative 3, and again there, negative 9 minus a negative 6 will give you a negative 3, and 4 minus 3 gives you a 1. So the division by 1, as it did here, will not change the constant difference. Okay, again, it's one of the properties under whole numbers, isn't it? The identity property of 1. So let us investigate term 1. Okay, let me rather use a different color here, a blue, to go for this one. Use red. So term 1, value of term 1 is 0. Okay, so using this equation, we know that we have a -3 as our gradient and we are at position 1. Okay, -3 times 1 is -3. -3 plus what will give you a 0? -3 plus 3 will give you 0. Okay, that is your C, yes? Let's check term 2. The value of term 2 is a -3. Okay, constant difference, it's -3. We are at position 2. Okay, -3 times 2 is -6. What must we do to -6 now to get to -3? We must add. We add 3. Okay, do you see the same thing is happening? Term 3, we have a -6. Okay, so our constant difference is -3. That's our gradient. And position 3 is where we are. -3 times 3 is -9. What must we do here to get a -6? We must add 3. Okay, so can we deduce now our general formula? Yes. How does it look like? It is Tn -3n plus 3. Okay, and that's it. We have done the second part, okay, or answered the second question. The last one, get term 62 now. Let's get term 62. How can we use the general formula to get the value of term 62? Substitution, okay? Must happen from left to right. This n and that n, 62 now. There's -3 times 62 plus 3. Let us now check with our calculators. We have -3 times 62 plus 3. Okay, and that gives us a -183. Okay, so yes guys, this is what we do at this level with this topic called number patterns. Okay, neat mathematics, clean mathematics. However, I want to emphasize the connection that we make to functions. Okay, so this equation is the basis of us doing this. It gives us the mathematical right to do that. Okay, so yeah, I believe you've enjoyed this. You have written some things down, and yeah, I'll see you then next time with another topic, something else and something challenging as well. So thank you for tuning in. Thank you for enjoying maths, sticking with maths and choosing maths. I'll see you next time. Sharp, sharp.